telling to anything more about the neural networks, just let me more clarify the difference between the artificial intelligence, machine learning, and deep learning. See, what is mean by the artificial intelligence? As we know, the artificial intelligence means the machine, how to become a machine as an intelligent. Okay, so that is the point we need to keep in mind. So how to become a machine intelligent? So see, a human can become intelligent by using their sensor, but in the machine we're talking about the sensor will be represented by the its artificial sensor. So definitely, what is mean by the artificial sensor? See, just like the smelling, just like the reading, just like the thinking, just like the vision. So if a human can just need to view anything, so it is possible by the on his or her eye. But if we're talking about machine, so machine will use a camera. If machine need to read some, machine need to think something, so definitely for computation is required. But how a human can think? Human can think by the user or using the brain, brain power we can say. But how a machine can uh, listen or speak? So we can say by using mic or speaker. But talking about the human, human can listen or speak by mouth or by listening by the ears. So everything will be possible as a human. So machine can also possible. So machine can be intelligent by their artificial things, and those can be recognized by the sensor. And if we expand over this concept into the various broad ways, so we have the something that is required to understand, that is machine. So if you are making a machine as a more intelligent, then machine should have the learning oriented approach. So at the time, machine learning is more important aspect. So artificial intelligence we have already studied, where we have found that what we mean by the artificial intelligence and how a machine can become intelligent. But when talking about the machine learning, so machine learning is basically the subset of the AI, and which defines that how a machine can learn. That is my point. So machine can learn by the various learning approach, and those are the supervised learning, unsupervised learning. And after understanding this point, we are expanding our concept into the more broadly into deeply way. So we have same concept we will expand into deeply way. So that is the point we have the deep learning. So deep learning is nothing which is only the subset of the machine learning, and which describe that when you're trying to solve any problem into deeply manner. So that is the point we can have, that is a deep learning. Right now I'm remembering an example, but a real example you can understand simple way. Suppose I am sharing ebooks to all the students. So what you will do? Okay, once a time you can read out. Okay, no problem. If I'm saying to okay, read once more, so you're just trying to read 2 or 3 times more, then I will ask any questions and you will able to give me answer in simple way. But I'm saying to all, the total number of the pages we have the 100, and you all have to read in deeply, and I can ask any page from, I can ask any question from the any one of the page. Then what you will do? You read the same book 10 times, 15 times, and maybe the 20 times, because sir can ask a question any, sir can ask the any question from any one of the page. So what you are doing? Same thing you are doing again for the deeply knowledge, for getting deeply knowledge. So that is what, that is a deep learning. So if we're talking about the to apply this approach, what we have, neural network play important role. So in the neural network, once we what we have to do, we have the input, we have the output. So input or output we know, but we are doing the processing again so many times. So that is to be done by the some layer, and that is to be handled by the neural network. So this is my point where we need to start the neural network. Okay, so input is, if we are talking about our same example, we have the input is a book, we have the output question may ask from the any one of the point. But suppose you are reading, or you are reading book 1 or 2 times, and I'm asking a simple question, then you are not able to give any answer. So your accuracy or output will be zero. So what is sense of reading such book? That is my point. But you are reading the book 10 times, 15 times, then I'm asking a question, then you are giving the 5 questions out of the 10 questions, you are giving the answer 5 answers out of 10 questions. Then you can say, sir, I have at least I have given the 5 answers, so my accuracy is 50%. So that is my point. Rather than getting the giving the 0% accuracy, it's better idea to give the 50% accuracy. That is my point. So deep learning is more important whenever we are trying to solve any complex problem by learning approach, but in deeply manner. So that is the important point. We need to take care of this point over here. So these are the biggest difference we need to take care about the machine learning, artificial intelligence, as well as deep learning. So from this point, if you have any doubt, then you can ask me. Just tell me. Okay, just tell me any doubt you have. And a Siri is the best example. Yes, we know what is mean by the Siri. Siri basically is a visual assistant concept, or is an application inside the Apple incorporation. So when you're looking for the Apple mobile, so definitely Siri is a good tool. So which support the all kinds of applications supported by the deep learning, machine learning, and anything. So this is a good example. Those students who have the Apple, so they have this idea about the Siri applications. I hope so. So now tell me any idea, any confusion you have right now? Difference between the artificial intelligence, machine learning, and deep learning. Okay, now tell me, students. From this point, you have any doubt? Please, you can ask me.
Uh,
Okay, Shriram, do you have any doubt?
no, sir.
So whenever I am asked this question any times into the examination, then you will be able to give the answer properly. Okay, any other student who haven't doubt, please you can ask me right now.
No doubt, sir.
Okay, so this is the basic difference is clear to all. I hope so. Okay, so difference between the AI, machine learning, deep learning is necessary part before doing anything on the machine learning. So you must be known to this point what you are learning, what you are gaining. Okay, that is my point. After understanding this point, you can observe this point which is to be highlighted over here. If you're adding of your grouping or you're integrating the all the concept AI, machine learning, deep learning, so all these are the interconnected fields as you can see over the slide. But machine learning and deep learning basically improve the artificial intelligence by the set of the algorithms. Of course, that is the point we need to keep in mind. In the machine learning, we have the lots of the algorithms and followed by the supervised and supervised learning. And I'm talking about the neural network. So neural network we are adding as a we can say the extension version of the improving the learning approach. So it is used to solve the complex problem which is following by the data driven problems. So that is the point we need to keep in mind when trying to learn something from the deeply. So deep learning is applicable. But when trying to solve any problem by using the very specified problem and we can solve, it's okay. But you want to know or you want to get the more accuracy, then what you will do? You will go for the deep learning. So that is so many things we need to take in our mind. So that is the neural network very important. So neural network is more applicable along with the deep learning. Deep learning is nothing very frankly speaking, deep learning is nothing. We use a machine learning algorithm plus neural network, so we are doing the deep learning. That is simple concept, and this is the practical way, very frankly speaking. So the neural network based approach are integrated into the our machine learning. So we have the deep learning. So that is a no. While learning deep learning, we will not introduce new algorithm. While learning a deep learning, we will not introduce any other kind of things. We will use the same algorithm. Just what we need to add, we need to add the neural network with the algorithm. Then we are doing the deep learning, and that is the my point. So from this point, you have a doubt. Still, you have a doubt, then you can ask me right now.
Sir, what is meaning of the data drive?
But what is mean by the data driven means suppose we have the huge amount of data set, very frankly speaking. So when we have the data set, so you just need to get the accuracy. So okay, if you're doing the machine learning algorithm, you will get the accuracy 88% or 92% or 95%. But machine learning, deep learning, you are approaching, you are trying to solve your problem by applying the many computation again and again to improve the accuracy on same data which is to be used by the machine learning, and you are applying the deep learning. So maybe there is no guarantee, maybe you can have the accuracy 99 or 98 97, which is better than the machine learning or previously defined algorithm. So that is my point. See, that is my point. I'm taking the simple example. Reading a book is what? The reading a book is a data. So what the data you have, on which data you are just reading a book again. So computation, your brain is applying the computation again for reading purpose on the same book. So same input we have, same output we will have different, because after reading the book one time, two time, it's okay, we can do. But after the reading the book again, so there will be one time or there may be some chance when the entire concept or entire pages will be in your mind in form of the some concept. So when you try to explore yourself, so now you will able to see or you will able to give the answer. Sir, you are asking this question to me which is written on this page number, because you have read out a book 20 times or maybe the 100 times. and that is the brain which is used by the Swami Vivekananda, very frankly speaking. So there is a story in the Swami Vivekananda ji, what he did while traveling from any place, one place to another places. So when we read out the book or any magazines, so he just put down after some time, so definitely within the after 1 or 2 hours, he just tried to put down the book into the dustbin, and different and the other passenger, or maybe the very next to the passenger, or asked Swamika Vivekananda, why you are putting that book into the dustbin. So he said, after reading the book, every concept my mind, so I know what is written on that page, and that is the beauty of the brain of the Swami Vivekananda. But we are not the Swami Vivekananda, but we try to read book again and again. So definitely our mind will keep the most of the concept which is written on the book into the our brain. That is my point. So data means the data whatever you have on which you are performing something, or something means some calculation. So that is my point. Now is it clear right now?
Yes, sir.
Okay, so data driven means we will do some activity on the our data set. Okay, now move to the next slide?
Excuse
Okay,
me,
sir.
sir.
Yes, tell me.
So I have a doubt, sir, as you have written on your PPT that we are providing set of algorithms and neural networks,
Yes,
right?
of course, of course. See,
So is
what
it
I
different? Neural networks are the set of algorithms, right? Or set of algorithms is different, and we are providing something. Neural networks
no, no.
in a different.
I will tell you. See, when you try to solve any problem, on what parameter you are solving a problem, what is the set of the rule on which you will apply to solve a problem. So that some algorithm is required, and that is known as set of the algorithm. And neural network is saying to us how many times is the how many times you will apply same algorithm to solve your problem. That is my point. See, just I'm explaining simple way, then you can understand. Just give me 1 second. Then what I mean to say that over here, see, this is the input you are having, this is the output you are having, and this is the processing you need to do on this input. One time you are getting the input for processing purpose, and then you are executing your information, then you will get some output. So that is what this is the followed by the some algorithm. Okay, so I'm writing here a means algorithm. But suppose you are getting the accuracy approx 80%. Now you will be happy, okay, my model is good, I'm getting the accuracy 80%, and it's okay. So this computation will be done by the some set of the algorithms, and that is to be done by the one layer. Okay, so that is one time you can say. But you need more accuracy. So what you will do, you will take the same input. So input will be same as it is, no changes. But output may affected by applying the computation again. So that is you are doing your computation by the multiple layers. So same algorithm we will have, but we will try to solve this problem by applying the n computation. Okay, this is the my point. N computation. Then maybe there is no guarantee. Maybe your accuracy may improve by 80% to 89%. Suppose you are getting so 9% accuracy we are increasing by applying the more computation. So that is my point. So set up the algorithm means some algorithm is required to execute your activity. Okay, so neural network means the layer we are using for computing purpose. That is my point. So now this is the point. Now is it clear?
Okay, sir.
Okay.
Sir, is it means there are different nodes where we are passing data and processing it, right?
Yes. Don't worry. I have the diagram of the neural network. Okay, I'm just let me remove your curiosity right now.
So because when we are in first semester, we were taught that neural networks are set of algorithms uh, which are modeled after human brain, and they we use neural network to recognize pattern. That's why.
My dear, I'm just coming step by step. Okay, now see this diagram. Now you will happy to remove your curiosity. This is input we have. This is a hidden layer. This hidden layer is specially used for the computation purpose. Then output layer. But if I'm just increasing the hidden layer, or means I'm increasing the computation, so I'm solving my problem in the complex manner. So definitely I can have. So what I'm applying indirectly, I'm applying increasing the set of the algorithm, set of the rules on each and every level again, and then my computation will be more and more. So definitely accuracy will be automatically high. See, you can see into the examination time while learning anything during the examination. You will try to mug up some pages for examination purpose. One time you are reading, okay, you are not able to understand. The second time you are reading, okay, you will feel okay, you are getting something. Then you will read again. Then you will again 5 to 6 times after reading. Then you will say, okay, I know what is the sense of these pages which is written over here. Then you will reply. That is my point. So layer by level or level by level, we are increasing our complexity, but this complexity will give us some better result. So neural network is not especially designed for the solve a norm problem. This is especially designed for to solve the complex problem where we need the more computation to resolve our getting the good accuracy or good, or we can say better result. So that is the mind. And this diagram, now after seeing this diagram, you will happy to see your diagram. So that is my part. So we are coming. Okay. So whenever you have went out, then you can ask me. But okay. Now tell me. Now your answer is clear. Your question is clear according to the answer, or do you have a doubt right now?
Yes, sir, it is clear.
Okay. So we are coming. Okay. Don't worry. We are coming. Okay. Okay. So now you will able to see this diagram. I hope so. Now let me know. Is it visible to all?
Yes,
Yes,
sir.
sir.
Okay, so let me remove the unnecessary point over here. Then I just need to explain something in better. Yes. Now, see, we know the neural network concept is totally inspired from the neuron. But what is the sense of using the neurons again? I am speaking. What is the purpose of the neurons? What is a neuron? So neuron is totally inspired from neural network is totally inspired from the human brain, and in the human brain is basically totally functioned by the neurons. And very frankly speaking, in our mind we have the more than 1 billion neurons, because everything to be stored into our mind. We can say the mind is very strong mind, or we have the good mind. So what does it mean? Because we have the good capability to store some information, and we have the good interpretation. By the interpretation, we can solve any problem. So the decision or the thinking power, so many things we can do by our brain. Same thing we can do here. So for telling to more about the artificial neurons, it's a better idea to let me explain some concept about the biological neuron. So biological neuron is stored into our human brain, where each and every neuron is connected to the many neurons, and where the information to be flown, where the information to be passed from one place to another place. But in the computer system, in the normal system, what we have in our real life, we have the input, we have the output. This is the first point. This is the second point I'm speaking right now. So what is third step on which you will get the something? So that is the processing. So without processing anything, did you are, or are you able to get something? No. So first will be our input, second will be our output, but processing is required. So but the channel or the sequence will be the input first will take, second processing will be required, and after processing we will get something. So three important aspects is required in the computing purpose in real life as well as the machines. Now, so input in the biological neuron, how we can take. So let me clear to all with this image. Dendrite is a dendrite is a part of the neuron which is able to take some inputs. So you can see this is a dendrite which is shown by the image over here. Just like the branch of a tree, you can able to see over here. That is a dendrite. And this is the our. I'm just marking over the slide. You can see this is the known as the cell body. This cell body is what? This cell body is just known as, this is the cell body. That is known as the soma as well. Okay, so this is also known as cell nucleus. In the cell nucleus, we have very small nucleus inside the cell body. Okay, and that is used to compute your thing. What you are, suppose you are thinking something, so the computation can be done at this level only. So after getting the input, where the process to be done, process will be done at the nucleus level, nucleus point. So our mind will take the input from the dendrite and computation will be done at the nucleus. This is my point. And after the computation, what is the next step? Our output. So output can be stored, output can be managed by the axon. And now you can see these are the various axon. Now you will able to see this point over here. Just let me make this concept in the zoom mode so you can able to see. Now, is it visible right now in the zoom mode? Is it visible? Okay, now tell me, is it visible?
Yes, sir.
Okay, so axon will represent the output. So axon is also managed by the some sheet that is known as the myelin sheet. Okay, but one axon is connected to the another axon. So what does it manage by the, that is known as by the synapse. Synapse is basically just like an interconnection between the axon and dendrites and soma. So this interconnection, all the things will be connected by each other by the some point that is known as synapse. And in a technical way, we have this term that is interconnection. Just like input device is connected to the output device, but before that processing device play important role. Same thing we can say, input point is connected to the processing point by the some bias, so that is interconnection. Same thing in the biological neuron, we have the synapse that is known as the interconnections. Okay, the output of the this neuron will be the input for the other neurons, and that is the my part. So because each and every neuron connected with each other, and that is just idea about the biological neurons. But when I'm moving to the this point, dendroid, cell nucleus, soma, axon, we know, synapse, we know. In the artificial neurons, those are recognized by the input and output, and this node, this node, and this is point, this is known as the processing point. Okay, and that is the interconnection. So these are the four different points we have by which we can understand what is meant by the artificial neuron. So after understanding the biological neuron, so let me just transform this biological neuron into the artificial neuron to explore more idea about the our artificial neuron. So as a dendrite, we can take the input, so we can represent our information like the x1, x2. So this x1, x2 is what? These x1, x2 are the input. So see, our brain is not able to take the single decision only. Our brain is not able to take the single input at the same time. Just like our brain, we can take the many input at the same time. Same thing, and the artificial neuron will be able to take the many input in form of the various values. Those are recognized by the x1, x2, x3, and so on, so xn. Here I'm just representing my information by the only the two inputs only. So okay, and f is what? F you can able to see over here. This f is what? F is a node. Okay, this f I can represent by the this node. Okay, these two x1, x2 input are represented by the input. I am just drawing this part only. Now fi is our output. So finally you have the three different things. And now let me clear to all once again. If you are giving input to the node, there is required some weight, and that is known as the W1, W2. You can observe here. So W1, W2 is what? W1, W2 is are the weight of the each and every input, and it decide which input you will take for activate your node. That is the my point of view. Okay, so this function is transformed into the summation function and followed by the some activation function. So FE can be brought into or expanded into the different way. So in the next diagram, or you can see in the bottom diagram, which is explained in a very well manner and which showing that x1, x2 we have the input followed by the its weight w1, w2, and we need to sum all these weights following by the multiplied by the weight of the each and every input respectively. So you can say x1 w1 plus x2 w2. So this process is known as a summation. And why we are doing the summation? Because this summation will move to the each and every node to each and every node of the hidden layer. Hidden layer means the for processing purpose for the each and every node of the next layer. And after applying the non-linear elements, because we will get this equation will be we can read as a non-linear element. Okay, this is not linear way, but the input we can take in form of the linear way. So the point we need to keep in mind, the input we are taking in form of the linear data, but the processing or the summation will provide the data in form of the some equation that can be transformed or identified into the form of the non-linear way. And after applying this some activation function or some function, we will have some output that is known as the y. So this concept is known as the artificial neuron, and if you are representing this neuron with some network, so that is known as the artificial neural network. So that is my point. So you have heard this term ANN. So okay, ANN. So ANN, you have heard this term that is known as the artificial neural network. So singly, if you are reading something that is neural network, this can also represented by the ANN in the system. So very frankly speaking, when you have about term neural network, so we can say we are talking about the artificial neural network. Okay, that is my point. So this is a little bit difference we have seen the biological neurons and the artificial neural network. Okay, now this point is clear to all. The difference between these two kind of the neurons is clear to all. Just let me know the status right now. Okay, any doubt at any point, please you can ask right now. Just tell me. Just tell me, any doubt?
No doubts, sir.
Okay, and I hope so in the fundamental of the AI machine learning, I hope so you have seen this kind of equations, and we will see each and every concept properly with some numerical as well. So in the next class, we will see all these things, but right now let us understand this concept properly. Now, let me explain this concept in more in broadly way so you can understand right now. This is another image, and in this image I have written some word over here about what is meant by the dendrite, cell body, axon. Because for the normal way, for the computation purpose, what we need input, output, and processing. So cell body is what? Cell body is basically represented by the processing unit, very frankly speaking, in our mind. And dendrites are used for the input purpose. So that is the input device we can say in our mind, in our brain. And axon is what? Axon is the output device in our brain. So that is the point we need to keep in mind. So you can see over each and everything over here. Now let me explain this diagram once again clearly so that you can understand each and every concept properly. So just see, I'm marking something over here on the slide. You can see what is these. These are the dendrites. Okay, so with these dendrites we can take the inputs. Now I'm just marking over here. This is part which is known as the soma. Okay, this soma means cell body. And internally we have this nucleus. This nucleus is what? It is used for the processing purpose. And now after processing, we will have some output, and that is to be managed by the axon. So this is managed by the axon. Okay, and that is covered by the myelin sheets. Okay, so in the previous slide you have seen. And now each and every axon, because we have the many axons, suppose we have, so each and every axon is connected by some interconnection points, that is known as the synapse. Synapse, you can just I can show by this point. This is a synapse. These are the kind of synapse. Okay, I can write synapse. Okay, so this is the point. So each and every point you are required to understand carefully. So whenever you have a doubt, then you can ask me right now. This is the point. So this biological neuron is clear to all. Okay, tell me, biological neurons is clear to all.
Yes, sir.
Okay, now shall we move to the next slide?
Yes, sir.
So biological neurons are artificial intelligence network. This is the biggest difference we need to take care of here. Why? Into the examination, there will be some probability I can ask or distinguish or differentiate the biological neurons or artificial neural network. So I think this is that will help you to more and clear way what is mean by the biological neuron and artificial neural network. In biological neurons, we can say all these are identified by the nerve cells. But in the artificial neurons, what we have? These are silicon transistor. Okay. In our mind, we have the more than 200 billion neurons and 32 trillion interconnections. So, but talking about the interconnection means synapses. But talking about the artificial neural network, so we have the 1 billion byte RAM. Okay, so that is talking about size only. Because information to be stored by the neuron in our brain, but the in machine information to be stored into the RAM. And trailing of the byte on the disk definitely that is to be used for the interconnections purpose. Neuron size we can have the 10 to 6 millimeter the size we can say, okay, but in the single transistor size we can have the 10 to 9 millimeter. So size is depend on the height of the person. We know this concept, so we will not bother about the other things. And energy consumption of course required in the biological neurons. So whenever you're thinking something, so some energy required. Sometimes you feel so many times after thinking so many times, so again about anything, so you will be feel tired. Oh, I'm so tired after the 1 hour I'm thinking about the thing, this concept, but it is not clear to me. Why? Because every time you feel this kind of situation, so energy is required anywhere. If we're talking in case of the biological neuron or artificial neuron network. So energy consumption will be 6 to 10 joule per operation per second. But same, we will go for the artificial neural, that is energy consumption will be 10 to 16 joule per operation per second. And our brain will be designed for the learning capability. So our brain has the learning capability to solve any kind of problem. But in the artificial neural network, we're talking about that is ANN or artificial neurons. What we do, the artificial neuron basically designed by the or some help of the, some algorithm, and that is we can say program. So with the help of the program, the artificial neuron will take the chance or will take the ability to learn something. So how this how we can say this possible is to be done by the artificial neuron by the set of the rules, set of the concepts, set of the programming. So because everything is based on the programming, if we are having a good programming, so we can say we have a good learning. Same thing we have the you sometimes you can say you have the good mind. So what does it mean? He has the good capability of thinking about the anything. So here we can say here we have the good program to solve our problems. So we have the good programming capability by the artificial neuron. And that is the point we need to keep in mind while solving any problem difference between the biological neuron and artificial neuron. Okay, so that is the point you have to keep in mind into examination purpose and whether for your career. So anyone can ask your difference between the can you difference the biological neurons or artificial neurons. So that is my point. Okay, now tell me any doubt over here. You are feeling any doubt right now? Please you can ask me. Okay, so tell me any doubt right now you are having.
No, sir, no.
Okay, so this point is clear to all. Difference between the AI, machine and deep learning, and difference between the biological neuron and artificial neural network. These 2 points are clear to all right now.
Yes, sir.
Okay, and after understanding this point, we will jump on our definition as I'm speaking. Neural network. Okay, so what is mean by the neural network? Rather than the mugging up the so many things or so many things, it's a better idea to let me explain to all in a very simple way what is mean by the neural network. According to me, you can understand. A neural network basically, as we know, it is a mimic of the functionality of the human brain. And what does by the human brain? We can say the human brain is a neural network made of the multiple neurons. As we know, our brain consisted by the 200 billion neurons. So according to me, a neural network is a network which is connected by the various neurons in which the problem or the complex problem can be solved by the simple way, and a neural network is handling over the problem or solving the problem by the various layers. Those are the input layer, hidden layer and output layer. So that is my point. So according to me, this is the point, but the question still comes in our mind, what is the point, what is the point or at which level the brain will work or the brain works, and that is the point we have the perceptron. The perceptron is basically a step or the concept or the point where the human brain work. So same thing, the perceptron we can understand by our artificial neural network, but let me clear all this point again. Perceptron basically multiple perceptron we will discuss in the coming lecture, but right now today we will see what is mean by the perceptron. So over the slide you can see the input layer, hidden layer or output layer. That's okay. I'm explaining this concept to again to all by simple way according to the problem. So that's why I have the very blank slide. Now I think you all are able to see the very blank slide. Now is it visible to all right now? Please tell me, is it visible to all? Is it visible to all? Let me know. Okay,
Yes, sir.
speak something. Okay, so just tell me how many node as an input I must take. So as an input, how many node I must take, and as a for the processing purpose, how many node I must take, and as an output, how many node I must take. But before, let me clear to all input node. We can take many output node. Right now we are taking one, so I'm just writing over here only. But just let me know how many input nodes I must take for solving my problem. Tell me 2, 3, 4, 5, 6, 7. Okay, tell me total number of the values of the input layer. Just tell me. Okay, now tell me.
Hello. Sir, sorry, on what basis we are taking or randomly?
See, I'm still asking many times, but no one is replying to me. So that's why I'm asking once again. I'm asking to all in a neural network how many input you are looking for and how many output you are looking for, and what so processing I will decide, and I will demonstrate how a neural network will look like as
Sir,
according to your
can we
demand.
assume? Sir, can we assume?
Yes, of course you can assume any
Sir,
value.
three. Sir, three input.
3. So as according to you, 3 inputs we are taking looking for, and right now I am taking the output for understanding purpose only one, that is sufficient only. And processing, we can take the 4 or 5. It's up to you. So now tell me what value I should take for the input purpose. You can take less as well.
4.
Okay, 4. And that is a data for solving our problem. So according to the students, so just what I'm doing, I'm taking the input. Now see 3 input node. These input nodes can be identified by the x1, x2, and x3. So this is the input point. Okay. I can combine these input point in a box for understanding purpose only. For understanding purpose only. Now this is known as the input layer. I can write over here, that is IL. IL means input layer. Now is it visible to all right now? This point is clear to all right now as according to demand. Is it visible to all?
Yes, sir.
Yes, sir, input
Okay,
thing is clear.
good. So now as according to processing unit, I am speaking over here. So for the processing over here we have the 4 different nodes. Okay, so we have the 4 node, and now we have the last one out. Again I am just putting into a box to explain my concept in simple way. Right now I am not following any kind of the bookish concept. I'm following the concept which is to be understandable by us in simple way. So according to your demand, I'm trying to solve this problem now. So if this question I can ask in the examination, we have the 3 input node, we have the 4 hidden node or processing node we can say, or at the hidden layer, and one output node, and draw the neural network diagram. So this diagram will help you know how we can draw. Now let me clear to all once again, my dear students, this is the output layer, so I can write OL, that is output layer, and middle part will be recognized by the processing, and that is identified by as a hidden layer. Okay, so the HL I am writing. So x1, x2, x3 are the hidden layer. Sorry, x1, x2, x3 are the input layer, and h1 I can say I can write h2, h3, and h4. So these are the my 4 different node which are known as the hidden layer node, and this layer is known as the hidden layer. So how many layers we have? One input layer, one output layer, one hidden layer, and here we have the output layer. So this can be identified by the O1. So O1 means one output node. Let me choose a different color to explain my concept right now. This is the node X1 will be connected to each and every hidden node. So I'm connecting over here. Now you can able to see here. Okay, so this node will contain the weight, so I can mark the weight W1, and so W1 weight for each and every node. Okay, same thing we will go for the X2 node. So suppose I am taking the X2 node by this color. Now you can able to see this node will be connected to this one. Same thing we can go for the W2 weight, WT weight for the X2 node. Okay, and W2, and I can write W2. Next we need to move by the we will connect the X3 input layer input node from the input layer by each and every node at the hidden layer. So we are connecting. Now we have connected. Same, it contains its own weight, so that is identified by the W3. I am writing over here W3 and W3. See, let me clear it all once again. This can be done by the input layer, so no issue. This is done by the hidden layer. Now, this hidden layer will take the, just let me explain here right now, this H1. So H1 is a hidden node which take the input from the X1 along with its weight. So I can write X1 W1 plus hidden node is also taking input from the X2. So we can write X2 W2 plus it also taking input from the X3. So I can write the X3 W3. What I'm doing right now, you can say I am doing the summation operation, and this is the important part of the our column. So H1 will be identified by the X2 or X1 W1 plus X2 W2 plus X3 W3, and this value will be input to the H1 node, and in the at the input node we will apply another function, and that is known as the activation function to fire your neuron in your human brain, or same thing we can say to activate your neuron, to activate your this node we have the some function that is known as the activation function. So at this point what we have, we need the activation function. Okay, that is the point you need to keep in mind, and this activation function is also known as the transfer function. So I am just writing in simple way, it's known as the activation function. Now this point is clear, just tell me this point is clear right now.
Yes, sir.
And
Yes, sir.
this H1 node will generate some output, so that is to be connected to this node. H2 also do some activity, it also generates some output, and so every node will generate some output. So suppose it is generating some values like I'm just assuming values 0.3, 0.4, 0.1 and 0.2. So the output layer will keep the optimum value or a very appropriate value to check what is your expected values and what is your actual values. So you are expecting your output should be around 0.5. So we will choose the 0.4, and which is very closest to the our expected output. So definitely the H2 node will generate the same output. So we will say now we are getting the same value. But suppose all these hidden node H1, H2, H3 or H4 are not close to our value, so we will do some different activity. So before telling to all this concept, just let me explain some more idea about this point over here. So far what we are doing, we are doing the, see what we are doing, we are doing the forward neural network. We are representing diagram that is known as the feed forward neural network. So this diagram is known as the forward neural network of forward propagation we are doing, because we are moving from left to right or we can say input to output, or input to hidden layer to output layer. So this approach is known as the forward propagation, and this kind of the neural network is known as the feed forward neural network. Okay. Suppose I'm backing to the my point. Suppose after getting the some value, we found that our expected value should be 0.5 or 0.6, but we are observing over here we are having value 0.2, and which is like not close to our answer. So what you will do, you will try to we will try to back to your hidden layer, and then hidden layer to input layer. So at the time, what you are doing? You are doing the backward propagation. So backward propagation is a method of technique which decide when your answer is not meeting your criteria, then you will try to resolve this problem by updating the weight of the input layer. So after updating the weight of the input layer, new values for the each and every node at the hidden layer will be generated, and respectively after applying the activation function, new output to be generated, and then we will meet again. If you are not meeting, then again we need to go for the backward propagation. So backward propagation is what, that is a technique which decide that you need to do perform many operations for solving your problem till you are getting the correct answer. If you are not getting your answer toward your if you are toward your expected answer, then you will do same activity again and again. So that is why neural network is important. So backward propagation is a technique. That is my point. And at the time we are doing the backward propagation neural network. But in this case, no backward propagation required. Suppose we are getting the same, we are getting the expected answer. But by default, we are having the neural network that is known as a feed forward neural network. Now, this point is clear. Before explaining more, so this point is clear to all.
Sir, back propagation is not clear. Please verify.
Backward propagation I will explain, but just let me know this point is clear to all. Feed forward neural network. By default, we have a neural network that is known as the feed forward neural network.
This is clear, sir.
Okay. After getting this, just let me the answer from the other students, please. Is it clear to all? Because it is fundamental part. Is it clear?
Yes, sir.
Okay. So backward propagation is saying to us, suppose I'm taking the different values for explaining purpose right now. Just give me yes. See, suppose you are expecting answer, you should have the value 0.7. Okay. So you are expecting the value that is, you have the some values. You are expecting you must have the your answer 0.2, sorry 0.7. That is your expected answer. So I can say this is your expected value. Okay. Or we can say this is actual values. You decided you must have the output 0.7, but we found that 0.3, 0.4, 0.1, 0.2 are not close to. If we are choosing any one of the values from the these values, we are not close to the 0.6. Then what you will do? What you will do? Okay. Let me explain why the different. Let me explain by the diagrammatic way. Then you can easily understand. Uh, just give me 1 second. By using a highlighter. Okay. So what you will do when when you are not getting your expected answer very closest to the expected answer, we can say, then you will move from output to hidden layer, and output to hidden layer, hidden to input layer. Now this backward step is required. But what you will update at the output layer, what you will update at the input layer, what you will update at the hidden layer, that is an important point. So in this point, you can able to see here, weight is a point by which we can update something. So weight is what? Weight is what? Weight is the random value that is to be associated with the each and every node of the input layer. So if you're updating the some values of the weight, so definitely the input values along with the weight of the each and every node will be updated. So that is my point. So there will be some rules and regulation by which we can update, and there are some approach by which we can update the values. But after updating these values, now new values of the each and every node h1, h2, h3, h4 will be generated. And now next, after applying the activation function on each and every node, so So we will get the some updated value rather than 0 0.3, 0 0.4, 0 0.1, 0 0.2. Maybe we can have the 0 0.5, 0 0.6, 0 0.7 or 0 0.9 something. So if you see now we are expecting 0.7 and now in the other output values we are having 0.7, so we can say we are getting the our expected value as we have desired from the neural network. So there is a reason, that is a reason which is described that in the neural network we will have the good accuracy. There's no guarantee 100% accuracy, but we can say the more than 90% or 95% we can have the good accuracy in the neural network. This is the reason neural network is growing into the research purpose only. That is my point. So now is it clear? Now tell me, this point is clear?
Yes, sir.
Okay. So backward propagation is not easy to solve any problem backward propagation in a one day, 2 day. It required the 6 to 7 lectures. That is my point. It requires 6 to 7 lectures to explain each and every concept properly. So backward propagation means you are propagating your neural network by applying output to the header into input. But what you are changing, you will changing or updating the weight. And along with this weight, we have some bias. The bias is not mentioned over here, but we have suppose we have the bias. Okay, I can write this short. Suppose we are using the bias, and that is a necessary point to improve your activation function. So bias will be associated with your input layer to improve the efficiency of the activation function by removing some errors. So if you need to some more good efficiency of your activation function at each and every node, then bias can be added. Bias is the optional part, but if you're adding the bias, it is good. So bias will be any values, and bias value of each and every node will be same. That is my point. So W1, W2, W3, W4 can be the weight of the each and every respectively node of the input layer. But when talking about this bias, so bias will be the common for each and every input layer node. So that is the point. What is the bias and what is the other thing we will see step by step. But just this is the point you need to keep in mind. So what is the bias? Bias is a value that is a parameter which is used to improve the efficiency of the activation functions to avoid the unnecessary remove or unnecessary or remove the some errors. So that is my point. So feed forward network is by default network is known as a feed forward network because we are using a forward network. Okay, and we are feeding the some inputs. That's why it is known as the feed forward network. This is the example of the single layer input layer. This is known as this example of the single layer neural network. So can we say this is the how many layers we have? Can we say can you tell me how many layers we have?
There are basically three layers: input, output, and feeder.
Yes.
But each and every layer, how many layers we have?
Yeah.
Now tell this. One layer.
Single.
Yes, sir. Single.
See, each and every layer we have only the one layer. Okay. Each and every layer we have the one layer only. So input layer can always be a single layer or single one. We can singleton we can represent it by the input layer, and singleton of the layer at the output layer can also be identified by. But just give 1 second. Just let me this part. Yes. Suppose I am having this kind of diagram. Now this diagram is visible to all.
Yes, sir.
No. Now I'm just choosing different color to explain my idea. Can anyone tell me what is this? Just so I'm marking in the circle in the red color. So
Input,
can
sir.
this
Input
is
layer.
a
Single input layer.
Yes, sir.
input layer.
Yes, sir.
Okay, can we have the multiple input? Can we have the multiple input?
Yes, sir.
Yes,
We can
Yes,
have the
right.
we can have the multiple input by the each and every node. So we can represent by the this one. Okay, that is my part. We can have the many input by the each and every node. So that is only sufficient represent by the input layer. That would be one only. And this is the output layer. We have only the right now the one node. So we can say there will be a one point. So that is represented by the output layer. Now this is what. Now tell me, this is what. These are what these two.
hidden layer.
Hidden layers.
See, these all are recognized by the hidden layers. Now we have the multiple hidden layers. We have the one hidden layer, we have the two hidden layers. So how many layers we have? The two hidden layers. When we have, now keep in mind, in our neural network there would be only one input layer and one output layer, but hidden layer can be many. So when we have the many hidden layers, this kind of the network, neural network, is known as the multi-layer 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 neural network. So that is my point. Okay, so here we have not a hidden layer, we have the hidden layers. Okay, so this is the my point. This is known as the hidden layers. Okay, now tell me any doubt.
No, sir.
So after seeing this diagram, now tell me what is can we say this is a multiple multi-layer hidden layer multi-layer neural network? No, because in this we have only the one hidden layer. So this is an example of the neural network, but this is not example of the multi-layer neural network. This is an example of the single layer neural network. So I can write over here, this is the example of the single layer neural network. Now this point is clear. So now the layer concept is clear to all. Now neural network, the basic idea is clear to all, right? To all the students, please tell me, is it clear to all?
Yes, sir.
So
Yes.
see, yes. So with the other slot, I have explained this example, same example I have explained to the other slots. See, I am explaining this example to you. I have explained this example to other slot. I have explained this example to you. I have explained this example to other slot. Now listen. This input in the artificial neural network can be identified by as an input layer, but in the our human brain can be identified by the dendrite. Okay. Now this is a processing unit, or we can say this is a processing unit general term, but in the hidden layer. The hidden layer is what? Hidden layer is basically used to compute your calculation. Okay, that is my point. And that is can be identified by the cell body in our human brain. That is known as the soma. Okay. Output layer, we have the output, and that is known as axon into our human brain. So I have just written this point over here for explaining purpose only. And now each and every node is connected by the some points that is known as the interconnection point, and that is known as the synapse in the our human brain. So we have the same sense, we have the same thing, but only the naming of the each and everything are changed. So now this diagram shows to we have the same concept, just like the neural network working. So neural network is what? Neural network is just working like our human brain works. That is my point. So after understanding this point, after understanding this concept, you can say now you are able to say yes. We are inspired from the our we are understanding the inspired concept neural network from the our inspired part, that is the human brain. So we have the inspired concept from the human brain, that is a neural network. So from this point, what is I mean to say that this is the basic fundamental point I need to explain. So I have explained. So now tell me any doubt so far you have, please you can ask me right now.
So can we have multiple outputs?
We can have, but if we have the multiple outputs, so which output you will choose? This I have this diagram. Just let me complete this. I am coming. Yes. See, we have the multiple output y1, y2, y1, y1 to yn. So you have to choose only the one output. That is your optimized output. You can have the multiple output, but you can't have the multiple layer in the output for the output layer. That is my point. You can't have the multiple layer of the input layer and output layer. You can have the multiple output. You can have the multiple input. That is my point. Okay, input node only, but you can't have the multiple layer. Multiple layer is possible at only the one layer, that is hidden layer. Hidden layer can have the multiple node as well as the multiple layer. That is my point. Now this point is clear.
So it means if we want
Yes.
multiple output, then there will be only one hidden layer.
No, it's not so. I'm just again just remove your curiosity once again. Just let me speak. We have the one input layer, one hidden layer, okay, and one output layer that is connected. This is example of the single layer neural network. Now is it clear?
Yes, sir.
Okay, we can have the many input nodes for, because now we have the many inputs. So this can be an example of the single layer neural network. Now this is possible.
Yes, sir.
Okay, so this is the input layer, this is a hidden layer, and now this is the output layer. We can have the many output. We can have many outputs. Suppose we are having right now. So this can be example of the single layer neural network. But we have the many outputs, so definitely the multiple computation is required over here. So now we can have. Okay, I just randomly drawn, not possible to connect it by. So I'm just for explaining purpose. So now we have the one input layer, one output layer, one hidden layer. So this is also example of the multi. No, it is example of the single layer in single layer neural network. So now this is my point. Now, you can have only a single layer at the input layer. You can have the many node at the output layer, but output layer input layer will be only the one. So that is my point. The output layer and input layer we will have only one. Hidden layer we can have one or n. So when we have the one, so we are talking about the single. When we have the multi, more than one hidden layer, so what we are doing, we are talking about the multi. That is my point. Now suppose I am just updating this network by adding the extra hidden layer right now. I'm updating. Okay, I'm updating by the 5 nodes at the hidden layer. So we have the hidden layer 1, hidden layer 2, and again this will be connected by like this one. Every node must be connected. Okay, so there is no guarantee. If you are connecting, then it's good. So now this point contains, we have the multiple hidden layer. Now this example is transformed into the single to multi-layer neural network. Now this point is clear.
Yes, sir.
Okay, so you need to understand where we have. Let me clear to all once again. Output layer, input layer will be one, but it can have the many node. Many nodes means many input and many output. That would be possible. But as a hidden layer means we can have the single layer, and it means we're talking in the single layer. It can have the many node. It doesn't mean we're not talking about the number of the node. We're talking about the number of layers. Okay, that is my point. So now this point is clear.
Yes, sir.
So all these diagram I will share to all. Don't worry. So you can utilize all these diagrams for your notes purpose. So now, so after understanding again so many things. So how many layers we have? Only 3 layers: input layer, hidden layer, output layer. And from this point, we need to keep in mind, I have marked over here in the hidden layer, that is necessary point. In this layer, the computations are performed which results the output only. So computation can be done at the our which layer? Hidden layer. Please keep in mind, hidden layer basically used to for the computation purpose. Input layer, we are inputting what we are inputting, it is okay mentioned over there. What is the output we are getting, what is the expected output we will get, that is mentioned by the output layer. But what is the processing we have to apply, at which level we have to apply, that is hidden layer. So this is my point over here, my dear student. If you are having the single layer operations, it means you have read out the book one time, but you are reading the book again and again many times. So what you are doing, multi-layer multi-layer neural network is saying to us, it means you have the many computations to solve your complex problem. It means now, because you have done the studies thoroughly, so now we can say the multi-layer neural network provide a better result than the single layer. And where the multi-layer neural network is applicable, I will explain in simple way today itself, don't worry. So that is my point. But before jumping on that part, let me explain the other concept that is necessary part, that is the perceptron. Okay, so this layer is clear to all right now? Tell me, this layer concept is clear to all? Just tell me, this concept is okay. Any doubt in the layer? Tell me, any doubt?
No, sir.
Okay, so we have already discussed.
Sir, just a query. Sir, in the
Yes.
last we chose any of one output. Means after the hidden layer we get like 0.3, 0.4, and 0.2. So the one we need we selected.
See, we will not select this point. The output layer will decide how many input we are getting. So output layer, the different output of the each and every node will be the input for the output layer. So at the output layer, we have the some other function by which we will choose. Not we will choose, the machine will choose, our algorithm will choose. So with the mathematically we're trying to solve this problem, so it requires the 6 to 7 lectures with difficulty as I spoke. We will try to solve this
Sir,
problem. We will try to solve this problem within the 2 lectures. But now tell me.
so here the output value is predefined, right?
Yes, output, no, output value, yes, we can say, and that is the actual output what we are expecting. Suppose I am expecting 0.7, but after the neural network computations, we are getting the various value. Those are the 0.3, 0.4, 0.1, and 0.2. But none of these values are matching with the our expected values. So we can say we need to update something, so that why we can update. Suppose we are choosing the value 0.4. So if we are choosing 0.4 and 0.7, so this is the biggest difference, 0.3 difference we are getting. So accuracy on this neural network is not good. So for updating your accuracy or for increase the accuracy, what you will do? You will apply the backpropagation. Backpropagation, what is the backpropagation? Backpropagation, in the backpropagation, we need to update something, and at what level you can update? Only the weight. So after updating the weight, your hidden at the hidden layer, your node information will be updated automatically. And again, based on the updated information, apply the activation function, your new output will be generated. So this process will go on, and this process will go on till we get the good accuracy. So that is a good thing. But after updating, after applying the backpropagation again, the cost of the neural network will be high. And to avoid the such things, that's why we have the neural network. So in the multiple neural network or multi-layer neural network, what we do, we will have the same input. We have the some weights. So rather than the increasing the more computation over the input, output, and hidden layer, it is better idea to increase the number of the hidden layer, because computation will be done at the only hidden layer only. So that's why the multi-layer neural network is better than a single layer neural network, because this computation you are doing again. So we will filter about our information. See, we have the one book only. So input we have the same, output we need to do, there could be anything. So we are improving the our result for the output purpose only. So what you are doing, you are reading the book again. So you are increasing the computation only. So rather than the updating the weight, rather than the updating the cost of the neural network, it is better idea to increase the number of the hidden layers. So automatically your model, which is following by the multi-layer neural network, provide a better result rather than the single layer. That is my point. Now tell me. Yes, now tell me.
Sir, to get the output from
Yes.
to get the output from the hidden layer, we select any output from the hidden layer, or we will manipulate them or
No,
subtract
no,
or
no,
add
no.
something.
There is some functions by which we have to manipulate. It is not easy to do. See, there is some mathematical computation. There is something we have to do. I am just giving the overview only how neural network look like and what we are expecting from the neural networks layers. That is my point. We have some functions. We have something by which we have to do. This is
Sir,
a
as of now, we can think from the hidden layer we will get some data, and after manipulate them or process, we will get the output.
yeah. Let me clear to all right now once again. The output of the input layer will be the input of the hidden layer. The output of the hidden layer will be input of the output layer. So at the output layer we have some other functions, and this function will decide which value will choose for the optimum purpose. Because now we have the multiple output right now. Suppose we have. So which value I should choose? I should choose the optimum value and which are closest to the output. So from this point I can say 0.12 I will pick, but I found 0.4 is not closest to the 0.7. So again what I will do, I will do the back propagation. So back propagation is a concept only. Okay, but rather than applying the back propagation, the better idea to your model should follow the multi-layer. But definitely you are doing the computation will be high. So you belong to the complex computation, and to solve the problem, such kind of problem, it is not easy. See, each and every layer we have some functions, we have something by which we have to calculate it. There is some formula. So it is not in our hand. It is managed by the neural networks only. It is not our hand. Okay, we will try to solve a mathematical problems definitely. Don't worry. Okay, we will try in the next class. Okay. Yes. Now tell me.
Okay, sir.
Okay. So now tell me any doubt in the hidden in this layers concept?
No, sir,
This.
no doubt.
No doubt.
Okay. Good. Okay. Now questions we have in the what does the neural network works within the 2 or 3 minutes I can explain simply. So just please stay connected with me. To understand a neural network, we need to break it down and understand the most important basic unit of the neural network, that is the perceptron. So perceptron is what? A single layer neural network is also known as the perceptron or perceptron. But what is the multiple perceptron? As I told you, I will tell you to the next class or lecture class. So just let me clarify in simple way, because we have a different diagram of the multiple perceptron. But what is the multiple perceptron? Multiple perceptron means multi-layer neural networks. That is my point only. So you have to keep in mind this important point. So neural networks will work on the basis of some perceptron. So that is perceptron means we are talking about the single layer neural network. We have this diagram. Okay. In this diagram, you can see what is the mean by the perceptron and what is the thing. A perceptron is a single layer neural network that is used to classify the information into the 4 components, and those are input, weight, and wise, summation functions, activation, transform, information function. See, this is a diagram which describes the each and everything so far we have seen. Now you can observe here x1, x2, and xn, so on. These are the various input, and w1, w2, and w1 are the respectively weight. And processing element to be managed by the summation function. Summation function can be write summation of the xi, wi, and I is equal to 0 to n, and that is summation function. And we will pass this value to our hidden layer, and hidden layer will compute something based on the activation function, and that is known as the transfer functions. Okay, this is the my point you need to keep in mind. And after this activation function applies the hidden layer, so hidden layer generates something. So suppose we have the n number of node at the hidden layer, so each and every node will generate some different output. So we have the multiple output. So now that is represented by the y1, y2, and yn. So y is what? Y is the output layer. It can have the many outputs. So that is the my point. Okay. So this diagram is represent the perceptron, and this perceptron diagram is also recognized by the artificial neural network. So when we say artificial neural network is what? Artificial neural network can be identified by the perceptron, and that is a good example of the single layer neural network. So this is this idea. So neural network will work on the concept that is known as the perceptron, and that is the example of the perceptron. Now is it clear? What I'm speaking over here, and that is written into the bottom side. Okay, that is written over the bottom side. You can see it out. But right now, tell me any doubt in this diagram so far we have discussed.
No, sir.
Okay, so this is the point we need to keep in mind. So theoretically, you can observe here what is meant by the weight and bias. So many times I told you weight is required and that is a
Sir,
random value. Yes.
can we continue from the next class? We have a class after this.
We have the two slides only. Okay, we have the two slides.
Uh,
We have the two slides only.
okay, sir.
We have the two slides. So after the two slides, you can leave. Okay, don't worry. So weight and bias is, let me explain to all in single words. Weight means there will be some weight of the each and every input that is a random value. Okay, and that is to be generated by some mathematical formula, or we can say it is generated by some algorithm. Bias is a parameter on the other end, and that is allowed to adjust the activation function curve in such a way that is the precise output we can achieve. So that is the point we need to keep in mind. I am speaking again and again. But the summation function, what does it mean by summation function? Summation function can be identified by like this one. I is equal to 0 to n, and we have the, suppose we have the x I and wi. So we can multiply these two values. So this is summation value. An activation function you can understand by the 10h, ReLU and sigmoid. Into the my previous lecture, as I told you, what is mean by the sigmoid. Sigmoid is what? Sigmoid is itself is activation function, and that is used into the logic regression as well. So 10h, ReLU are the activation function. It is my promise to all the students. I will demonstrate activation function 10h, ReLU, sigmoid in a single program to demonstrate what is the value we are getting. So activation function is especially used to activate your neurons in our mind. Definitely. So activation function in the artificial neural network is activate your hidden layer node. So this node is required to, at the hidden layer, the node will be activated. So how it is possible? So activation, some active function is required, and that is known as the activation function. So the node will be activated by the function that is known as the activated function. That is my point. Okay, so this is the end of the today's class right now. No problem, and we now we need not to bother about the other things right